Bismillahirrahmanirrahim. Good evening, everyone. Today, our lecture will talk about the wavelength. We will try to explain all the important information has related with this topic, and we will try to answer many questions have related with the wavelength. Let's start. This the first slide is the outline. I will start from introduction and after that going directly to answer many questions like what longer wavelength, who the Broglie guy, and what the important equation to belong to this guy, and many questions like the benefit and the disadvantage, who of them will be harmful to human eyes, and how we can determine the wavelength, and many important words like frequency, like the period, and by using many diagrams, many images to can do great idea to great understanding to this topic, because it's very important to me, because maybe my next seminar will talk and explain more deep information related with this topic. Let's start from the questions and we will finish our lecture from the summary and conclusion. Let's know who is the Greek letter lambda and why we use this word always lambda. This lambda belonged to this physicist man. His name was a Greek letter lambda, because that we say lambda. In physics, the wavelength, the special period of periodic waves. That's mean, let me explain that. The distance between 2 points belong to the same type. Here, the distance between 2 upper points at the top point on these 2 mountains, or we can say reversely between 2 these points, but the deeper 2 points, but we're dealing with the same condition. The 2 points must belong to the same type. Let me put arrow here. Yes. Here, by the situation, will be easier to understanding. Now, what that means? What the wavelength? What the wave of the wavelength means? As the distance, like I said before, distance between corresponding points of 2 consecutive waves. What is the length of light? We will dealing with length of light, and after that we will discussing the length of electron, and we will do something like simple comparison between all of them. It is the visible light. That means the length of light is the visible light spectrum, and we will use diagram to explain to us starting from which nanometer and finished with which nanometer, and which of them will be harmful to us, to human eyes. The visible light is the segment of the electromagnetic spectrum that the human eye can view. Any nanometer number, the human eyes can see it clearly. More simply, the range of wavelength is called visible light. I mean, from 380 to 700 nanometer will be, this range will be the visible light to us. Typically, the human eye can detect wavelength from, like I said before, 380 680 to 700 nanometer. This diagram is great, this image, sorry, is great to us because here the visible light start from 400, or we can say 380 nanometer, and we'll finish with the 700 nanometer. More than this number will be the infrared radiation field or place or range, like we know, we can say any word, acts this behavior. And less than 400 nanometer will be the ultraviolet radiation. Both of them, the human eyes can't see it, this fact, no way. Just we can see it by using another tools. The human is created all of them, but normally situation we can't see all of them. Just we seeing the visible light, the nanometers inside the visible light. Start from 400, we can say nanometer, finished with 700, and this another image explained to us the ultraviolet radiation starts from 100 nanometer, finished with 400 nanometers, and it will be harmful to us. And the infrared radiation starts from 800 nanometer and finished with 1 millimeter. We must be careful with units. And in my opinion, the infrared radiation is also harmful to human eyes. Like I said before, these two numbers will be the minimum wavelength at the violet light and the maximum wavelength finished with 1 millimeter will act the red light. What determines the wavelength? Let's think about that, how we can determine the wavelength. By measuring, like I said before, the distance between 2 points belong to the same kind, up or down, between any two corresponding points on adjacent waves. Adjacent, that means something like neighbor. I use the same image here to make the situation be clearer to us. Adjacent waves, that means neighbor waves, are the same line, up or down. A measurement is made by measuring the distance from a corresponding to the next corresponding, or from refraction to the next refraction. Refraction, this the downside. After that, we will talk about the frequency and we'll explain it. Now, after that, let's talk about how we use the wavelength, why we use it, why it's very important to us. Because the properties, by using the measure and describe, by using it, we can measure and describe all these types of waves, because that is the important tool to us. By using it, we can measure and describe all type of waves. What is the frequency? Frequency, it's important thing, it's phenomena when we're dealing with any wave has a bigger wavelength or small wavelength, the both of them will facing with the frequency. Let's know what that means, this word, the frequency. The frequency is the number of waves that pass a certain point. Let's say here, this at certain point, at this certain line, and but we're dealing with an important condition. Let's know what is this condition and specify the amount of time. Here, that means the time is constant to both of them. Trough is the low point of the wave cycle. The inversely wave, the same, both of them has the same meaning. What that's mean here, when we see these two images, A and B, here the wavelength is bigger than the wavelength at B, but here will dealing with more frequency at P image more than A image. If the length of a light wave is shorter, what will happen and what is that means? That means the frequency will be higher. Why? Because the some relation calculate the calculate, or yes, we can say this word, this relation between the wavelength and the frequency. This inversely properties, or we can say inversely relation. What that mean? That mean if the wavelength increase, be bigger, what we'll see to the frequency will decrease, and something like that. Because one cycle can pass, why? Because one cycle can pass a shorter amount of time. Like I said before, we're dealing with the constant or certain amount of time. That means the longer wavelength has a lower frequency. What is the relation between the wavelength and frequency? Now, after we defined all of them, the frequency and wavelength, let's know what the relation. The relation between them, like I said before, reversely proportional, reversely relation to each other for a constant speed. When we dealing with constant speed. Why? Because all light waves move at the same speed in a vacuum. The number of waves created passing at given spot in 1 second is determined by the wavelength. What is the longest wavelength? Or let's wondering, we have what is the longest wavelength at the same time. If are we have a smaller wavelength and the longer wavelength, in which field we use it, why we use it, how we can benefit from this characteristic. Yes, we have the radio wavelength is the longest wavelength because it is the longest wavelength. We use it at this field, at radio devices, because by using it, we can send our signal to far away. What is the shortest? The shortest to gamma rays have the shortest gamma. What factors affect wavelength? What the important element can affect on the wavelength? This important effect is the medium. What does mean? That means when we dealing with wavelength, with the glass will be different when this wavelength is from the water, from the air, and something like that. Because that we say the medium is very important and affect directly on the wavelength. Let's take examples of the waves. We have many kinds of waves like sound, light, or water waves. The last one is the periodic electrical signal in a conductor. What is the period wave? Now we know what does that mean, the wavelength and its equation and the frequency. Now let's talk about the period wave. The period wave, actually it's time, but let's know in which time we're dealing. The time it takes for two successive crests. Successive, it's continuously. Crests, that's mean the up 2 points or up points. One wavelength, that's mean up 2 points. Like I said, belong to the same kind to pass a specified point. That means its time takes for continuously up 2 points, continuously to one wavelength to pass a specified point. The wave period is often referenced in seconds. Why? That means it's appropriate units. We can use it with the period wave. Why the wavelength of an electron is important? Why it is very interesting to us? Sure, we have many advantages. Let's talk about that because of their shorter wavelength to the electron. Like we know, the electron has a smaller mass, and we must know that, we must note it, the wavelength has relation with what? With the mass, but inversely proportional. What does mean? That means if we're dealing with particle has a small mass, that means this particle can make longer wavelength. Let's come back to our slide. High energy electrons have high revolving power. This is important to us. Higher energy electrons have a higher resolving power, bigger than visible light. Let's highlight it. Please. Yes. Consequently, an electron microscope is able to resolve finer net details than a light microscope. Let me repeat all of that. An electron microscope is able to resolve details than a light microscope. That's mean because that we're very interested with the electron, the wavelength electron more than light microscope or light wavelength. And the wavelength of proton is 1.3 dot exponential minus 14, and the wavelength of proton is smaller than the lambda of electron. What wavelength is harmful to humans? Like I said before, this area, the ultraviolet radiation less than 400 nanometer, like here, started from 314 and less than, will be harmful to human eyes. And at the same time, in my opinion, infrared radiation, it's too harmful to us if we don't do using appropriate tools to protect our skulls, our skins, and our eyes. How is the Broglie? Broglie, it's this name is important name in wavelength topic because this guy created to us the wavelength equation, and he was famous in another topics like quantum theory and predicting the wave nature of the electron, and he take the big prize. He was awarded with Nobel Prize at physics department, physics section at 1929, sorry. What is the Broglie wavelength equation? It was the wavelength equal Planck's constant dot mass of the object times the velocity of the same object. Let's go to the details and know what the relation between the wavelength and with momentum and mass. The wavelength that is associated with an object in relation, it's the momentum and mass, as known appropriately. Particles Broglie wavelength is usually inversely, let me highlight this part, inversely proportional to the force. Actually, honestly, it's not just inversely proportional to its force, but we're inversely proportional with another two elements. We will know it at the last this lecture, at the conclusion section. Now, what does that mean? The main point of the Broglie equation, what is it mean? Like I said before, lambda equal h m v, H is a Planck constant, the mass of particle, V is the velocity to the same particle. Planck's constant equals 6.602 exponential minus, like I remember, 34. To solve, now let's talk about the main point of the Broglie equation. To solve for the wavelength of the moving electron, to moving electron, what Broglie suggested? Broglie suggested that particles can show properties of waves. Particles can show properties, characteristics of waves. What affects the Broglie wavelength? The Broglie wavelength of a particle is inversely proportional to momentum. That means here now we have two inversely proportional to the wavelength. The first one was F, the second one was the momentum. Let's come back to what is the de Broglie theory. Any particle of matter that has linear momentum is also a wave. That's mean here we're dealing with condition. Any particle has a linear momentum. What that's mean? That's mean is honestly is wave. The wavelength of a matter wave associated with a particle is inversely proportional to the magnitude of the particle's linear momentum. This, the third element, the wavelength, has reversely proportional with it, the magnitude of the particle's linear momentum. Which has more wavelength, proton or electron? Like I said before, electron more than the proton, which has more wavelength. Yes, the electron has the longer wavelength from proton. Why? Because the electron has a small mass than the proton, and we know the wavelength has inversely proportional with mass. Here the summary to all of that. The conclusion: a longer wavelength means a lower frequency, and shorter wavelength means a higher frequency. And the difference between these two images, A and B, and the particles Broglie wavelength is usually inversely proportional, like I said before, with the force, momentum, magnitude of the particle linear momentum. That's it. Thank you about your patience, your watching. Have a good day. Let me stop recording. That's it.